Scientists claim that there is a disturbing shift that has affected the Earth's delicate energy balance. And these are views from the space station ISS of our Earth. Our living planet is unique among all we've been able to explore in the universe up to now, from our axial tilt preventing too many temperature extremes to our Goldilocks zone position. Life on Earth depends on a very fine balance, interwoven cycles that come together to produce the exact circumstances we need to survive on our Earth. One of these cycles is Earth's delicate energy system. It's the inputs and outputs of the energy received from our sun. This cycle dictates all planetary climates systems. On Mars, the seasonal change in energy imbalance, around 15.3% between Mars seasons, compared to 0.4% here on our Earth, is thought to cause the planet's infamously epic dust storms. For at least a while before the 1750s, this fluctuation energy cycle on Earth was relatively balanced, but we've now created an imbalance that's recently doubled in just 15 years. Quote, the net energy imbalance is calculated by looking at how much heat is absorbed from the sun and how much is able to radiate back into space, unquote, explains atmospheric scientist Kevin Trenberth from National Center for Atmospheric Research. He says it's not yet possible to measure the imbalance directly. The only practical way to estimate it is through an inventory of the changes in energy. Trenberth and Chinese Academy of Sciences atmospheric physicist Li-Jing Cheng reviewed data from all components of the climate system, that is, from land, ice, oceans, and atmosphere between 2000 and 2019, to conduct a stock take of these changes. Earth's atmosphere reflects almost 1/4 of the energy that hits it, unlike our moon, which takes the full impact of the sun's energy, leading to surface temperatures of around 212 degrees Fahrenheit, that's 100 degrees Celsius. That's boiling, of course. Most of that energy is then absorbed by the moon and radiated back out into space as thermal infrared radiation, more commonly known as heat. Again, it's the atmosphere that changes this process here on Earth. Some molecules in our atmosphere catch that heat before reaching space and keep holding on to it. Unfortunately for us, these are the greenhouse gases which have effectively now enveloped the planet in a too snug blanket at the top of our atmosphere. That extra trapped energy not only changes the place it ends up in, but also impacts the surroundings on the way to its final destination, the researchers explain. They say it's vital to understand the net energy gain and how much and where heat is redistributed within the Earth system, how much heat might be moved to where it can be purged from Earth via radiation to limit warming. While everyone has mostly been focusing on increasing temperatures, that's only one product of this extra energy. Only 4% of it goes into raising temperatures of land, and another 3% goes into melting the ice, Trenberth and Cheng worked out. And almost 93% is being absorbed by the ocean, they found, and we're already witnessing the unpleasant consequences. Although less than 1% of the excess energy whirls around in our atmosphere, it's enough to directly increase the severity and frequency of extreme weather events, from droughts to floods. But the increased atmospheric turbulence may also be helpful. Those weather events move energy around and help the climate system get rid of energy by radiating it back into space, the researchers explain. Clouds and ice also help to reflect solar radiation before it becomes long-wave heat that the gases trap, but both reflective clouds and ice are being reduced by disruptions in this energy cycle. There's still too much missing information from a comprehensive Earth system model that accurately predicts specific outcomes beyond the short term. Trenberth and Cheng said, but by incorporating the Earth energy imbalance framework that considers each Earth system component, this may be improved on. Modeling the Earth energy imbalance is challenging, and the relevant observations and their synthesis need improvements, Cheng said. Understanding how all forms of energy are distributed across the globe and are sequestered or radiated back into space will give us a better understanding of our future. The research was published in Environmental Research Climate and is by Tessa Koumoudourous on Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.